Assalamu alaikum. I'm Dr. Al Muhammad, PhD in Applied Mathematics from Egypt. For EDEXCEL AS Level Pure Math 1, we will solve in this video past papers problems on Chapter 4 Graphs and Transformations. For exercise A, question 5, the graph of y equals x power 3 plus bx power 2 plus x plus d is shown opposite. A, find the values of b, c, and d. Okay, the key of this problem is if y equal x plus 5 multiplied by x minus 2, who can tell me what are the x-intercepts here? Of course, it will be x equal minus 5 and x equals what? X equals 2. This is the inverse operation now. We already have the x-intercepts, which are minus 3, minus 2, and 1. And so that we can form the brackets. We can write here y equals x plus 3 and then x plus 2 and finally x minus 1. Let's expand these brackets quickly. We have here x plus 3. Expand these two brackets, give us x times x squared, x times negative 1, negative x times 2, 2x, it will be plus x, and finally minus 2. And then we expanding and simplifying, we will find this answer. So b here is 4, c is 1, and d is negative 6. B, write down the coordinates of the point where the curve crosses y-axis, which means put x equals 0, of course, right? For x equals 0, we will have y equals minus 6, which means that the coordinates of this point will be 0 and minus 6, okay? 6, the graph of y equals ax power 3 plus bx squared plus 6 plus d is shown opposite, where a, b, c, and d are real constants. Find the values of a, b, c, and d. What is the difference between this problem and the previous one? In the previous problem, the coefficient of x cubed was 1, but here a. Also, in the previous question, we don't know the y-intercept, but here we know already the y-intercept. So when we say y equal here x plus 1, because we have an x-intercept, x equal negative 1. And we have 2 and 3 here, so we have the brackets x minus 2 and then x minus 3. In this case, the coefficient of x power 3 is 1. But the problem don't say that. So we must put a here, okay? And then expand, keep a away, and also x plus 1, and expand these two brackets. We have here x squared, negative 2x, negative 3x, it will be negative 5x, and finally plus 6. Expanding, this is the result. Okay, now how we can get the value of a? Now we can use the information that y-intercept is 2. Since we have this point 0 and 2, we can put x equals 0 to get what? To get 0 here, 0 here, 0 here, 6a, right? 6a should be equals 2. By dividing by 6, a should be 1 over 3. So now we know all the function. A is 1/3, and then expand it to be 1 over 3 x power 3 minus 4 over 3 x power 2 plus 1 over 3 x and then plus 2. So a here should be 1 over 3, b should be negative 4 over 3, c should be 1 over 3 again, and finally d should be 2. 7, given that f of x equals x minus 10 times x squared minus 2x plus 12x, express f of x in the form x multiplied by this expression. A, B, C are real constants. Okay, a is very easy. We will expand these two brackets. F of x should be equal x times x squared x power 3, and then x times negative 2x, negative 2x squared, minus 10 times x squared minus 10x squared, and finally negative 10 times negative 2x will be positive 20x, right? Plus 12x. In this case, we can collect like terms, x power 3 minus 12x squared plus 32 x. X as a common factor, and then we have inside this bracket x squared minus 12x plus 32 as the question said. B, factorize. F of x in this case can be written in the form x multiplied by two brackets here x minus 8 multiplied by x minus 4. Their sum is negative 12x. And then C, the question said, sketch the graph of y equal f(x), showing clearly the points where the graph intersects the axes. Okay, to sketch a cubic function, we should follow these steps. First one, the coefficient of x power 3 is 1, right? So the graph will be increasing, decreasing, and then increasing, up, down, up. Then, if we put x equals 0, then y equals 0. This is the y-intercept. And then to get the x-intercept, we can equate all these brackets with 0. We have here 8 and 0, and also we have here 4 and 0, right? These are the information that we will depend on sketching the graph. So we have 0, 4, and 8. The graph should be like this, and down at 4, and then up again at 8, like this. Okay. Exercise 4C, question 5a, on the same axis, sketch the curves given by y equals x squared times x minus a and y equals b over x. A and b are both positive constants, okay? For the cubic graph, we have here x squared times x minus a, so that the coefficient of x cubed is positive, so the curve should be up, down, up, and also we have 0 and 0 and a and 0. So the curve should be like this, up, and on the 0 we will go down again and then up again at a. Okay, this is a, which is positive. Then to sketch the graph of b over x, it's a reciprocal function. X here is power 1, so we have two curves, one in the first quad and the second in the third quad, like this. In these cases, we prefer to label the graphs y equal b over x here, also here y equals b over x, and for this graph we can write y equals x squared times x minus a. B, using your sketch, state, give a reason, the number of real solutions. Okay, to answer B, we have here, of course, two solutions because we have 2 points of intersection. It will be 2 because we have 2 points of intersection. 6a, on the same set of axes, sketch the graphs of y equals 4 over x squared and y equals 3x plus 7. My advice to you in such questions, try to complete the question to the last sentence. B, write down the number of real solutions to the equation. In this case, he equates both y's together, right? Which means the question said, what are the number of points of intersection? Show that you can rearrange the equation to give x plus 1 times x plus 2 times x minus 2. Do you know? This means that we will have 3 real solutions. Hence, determine the exact coordinates of the points of intersection. Okay, very good. I will start solving this problem from D, because I will put x equal -1. In the first curve, we will have 4 over -1 all squared, which is 4 over 1, which is 4. To be sure that it's a point of intersection, put -1 also in the linear equation. 7 minus 3 is 4. Very good. The second one, x equals -2. For the first graph, 4 over -2 all squared, 4 over 4 is 1. In the linear equation, -2 times 3, -6, 7 minus 6 is 1. Finally, for x equals 2 over 3, we have here 2 over 3. If x equals 2 over 3 in the linear equation, 3 will cancel 3, 7 plus 2 is 9, right? Also, if we put x equals 2 over 3, it will be 4 over 9. 4 will cancel 4, and then y equals 9. So these are the points of intersection which can help us to graph or to sketch the graphs. So the answer is involved in the question here. For the first curve, since we have 4 positive over x squared power 2, so we have 2 branches in the second and in the first quad, okay, like this. To sketch the linear equation, we can put x equals -2 to be 1, okay, and also -1 to have 4, like this. And also we have 2 over 3, less than 1 here, and 9. So we can draw the following line. This is 9, and this is 4, and this is 1. This is the answer of A, and in the linear equation you can write here y equal 3x plus 7. For this branch, we can write y equal 4 over x squared, and also for this branch, we can write y equals 4 over x squared. To answer B, the number of solutions will be 3 solutions, right? To answer C, show that you can rearrange. Of course, we can multiply both sides by x squared, right? Times x squared to get what? To get 4 equals 3x power 3 plus 7x power 2. So we can rearrange it to be 3x power 3 plus 7x power 2 minus 4 equals 0, right? And also expanding all the three brackets will give us the same equation. You should expand all these three brackets and you will find that you will get the same equation here. 10a, sketch the graphs of y equals x squared plus 1 and 2y equals x minus 1. Okay. To draw x squared plus 1, it will be the same as x squared, but it will transform it above by just 1 point. So it will be like this. This is y equals x squared plus 1. And to draw this equation, y equals half x minus half, right? If we put x equals 0, y equals negative half, and if we put y equals 0, x should be 1. So this point is 1, here is half, and also here is 1 in y-axis. B, explain why there are no real solutions to the equation. To solve B graphically, we can say graphically there is no point of intersection, right? And we can say that algebraically, if we get b squared minus 4ac, it will be less than 0, of course, right? Algebraically, b squared minus 4ac will give negative 1, all squared will be 1, minus 4 times a, which is 2, times c, which is 3, it will be 1 minus 24, which is negative 23, less than 0. So we have two reasons here. C, work out the range of values of a such that the graphs of y equal x squared plus a and 2y equals x minus 1 have 2 points of intersection. Very good. 2 points of intersection means that the discriminant b squared minus 4ac should be positive, right? So we will solve them simultaneously and apply this idea. 2y means double y. Here's 2x squared plus 2a, 2x squared plus 2a equals x minus 1. Rearrange it to be 2x squared minus x and then plus 2a plus 1 equals 0. In this case, I will write ABC to be capital letters to don't confuse this with this a small here. A here will be 2, B capital here will be minus 1, and finally C capital will be 2a plus 1. And b squared minus 4ac should be positive. So b squared means here 1 minus 4a, which is 2, c, which is 2a plus 1, should be more than 0, and we want to solve for a. Okay, we have here 1 minus 8 times 2 minus 16a, and then minus 8 times 1 will be minus 8, more than 0, which means that 16a should be less than 1 minus 8, which is negative 7, and final answer should be a less than negative 7 over 16. Interesting question. This point should be negative half, sorry, okay? Negative half. Exercise 4D, question 6. The point P for a negative 1 lies on the curve with equation y equals f of x. State the coordinates that point P is transformed to on the curve with equation y equals f of x minus 2. Very good. So we have here an old point which is 4 and negative 1, and we want to make the following transformation: f of x minus 2. In this case, we have a translation horizontally, or a horizontal translation parallel to x-axis, and we will move the x coordinate here 2 points to the right. So the new point should be 6, and the y coordinate will not change. To answer B, Also f of x and then plus 3 for the same point, 4 and negative 1 by the transformation here. F of x, close the bracket, and then plus 3. This 3 is for the y coordinate. We will add the y coordinate by positive 3, okay, which means that 3 minus 1, 2. Very nice question. Question 7. The graph of y equals f of x, where f of x equals 1 over x, is translated so that the asymptotes are at x equals 4 and y equals 0. After the transformation, write down the equation for the transformed function in the form y equal 1 over x plus a. Okay, note here, I want to tell you a very important note. For the reciprocal function, if it is y equals ax plus b and then plus c, to get the horizontal asymptote, fx goes to infinity or negative infinity. In this case, this denominator will be infinity, and any constant divided by infinity will be 0, and then the horizontal asymptote will be y equals c. Okay, and to get the vertical asymptote, it means that equate this denominator by 0, because anything divided by 0 will be infinity or negative infinity. So if equating ax plus b equal 0 means that x equals negative b over a in this case. So now the question said the new asymptote will be x equals 4. X equals 4 means that the denominator should be x minus 4. And since y equals 0, the number beside this fraction is also 0. So simply the answer should be y equals 1 over x minus 4, just like this. Question 9a, sketch the graph of y equals x power 3 plus 4x power 2 plus 4x. To sketch such function, we can take x as a common factor, right? And then we have here x squared plus 4x plus 4, which can be factorized to be x multiplied by x plus 2 all squared. To sketch this function, the coefficient of x power 3 is positive, so it will be up, down, up. And we have 0, 0, and also we have negative 2 and 0 repeated. Or we can say that we have rebound point or touch point at negative 2. So the curve should be like this. Up and touch the curve at negative 2 and below again, and then up again and cut x-axis at 0. This is negative 2 and this is 0. And we can label this to be y equal x times x squared plus 2b. The point with coordinate negative 1 and 0 lies in the curve with equation y equal x plus a power 3 plus 4x plus a squared plus 4x plus a. If you look at this, the new y again, you will find that we replace each x with x plus a, which means that we make a transformation which is f of x plus a. So the question said the point negative 1 and 0 on the transformed curve. So we can write here negative 1 and 0. Okay, this is the point negative 1 and 0, right? So the transformation that should take place here is to move the curve towards right with one unit or to the left with 1 unit. If we move it to the left, the point 0, 0 will be at the point negative 1 and 0. And if we move it to the right with one step or 1 unit, the point negative 2 and 0 will be transformed to negative 1 and 0. So that the values of a can be positive or negative 1. This is the interesting answer. The challenge problem, the point q negative 5 and negative 7 lies in the curve with equation y equal f of x. State the coordinates that point q transformed to on the curve with equation y equal f of x plus 2 minus 5. Of course, in this case, the x coordinate will move to the left with 2 units, which means minus 5 minus 2, it will be minus 7, and the y coordinate will be with minus 5 here, minus 7 minus 5, it will be minus 12, move down 5 units. For B, the question said the coordinates of the point Q in transformed curve are negative 3 and negative 6. Write down the transformation in the form y equal f of x plus a minus b. Very good. In this question, the image is given, and also the original point is given, and we want to match them together by this transformation. Of course, now minus 5, how minus 5 can be minus 3? By adding 2 to it. So the new function should be f of x minus 2. Okay, minus 2. If I put minus 2, it means I will add 2 to negative 5 to be negative 3. Very good. And then minus b, we have here minus 7. I should add 1 to it to be minus 6, right? Plus 1, which means that a should be minus 2 and b should be minus 1. Question 7. The point P2 and negative 3 lies on the curve with equation y equal f of x. State the coordinates that point P is transformed to on the curve f of 2x. Okay, very good. If we have f of 2x, it means that we will multiply the x coordinate by the old point by 1 over 2. So it will, the new point will be 1 and minus 3. And for to answer question B, state the coordinates y equal 4f of x. If we have the transformation for f of x, we multiply the y coordinate by 4 to be 2 and minus 12. It's so easy. To solve question 8 here, the question said the point Q, negative 2 and 8 lies in the curve with equation of x. State the coordinates. Okay, the transformation now is f of half x. In this case, we will multiply the x coordinate of Q by 1 over half, which is 2. So it will be 4 and negative 4, sorry, negative 4 and 8. Okay. Question 9a, sketch the graph of y equals x minus 2 times x minus 3 all squared. We will cut the curve here at 2 and touch it, just touch it, or rebound at 3. But in all cases, the x-intercept will be 2 and 3. And to get the y-intercept, we can put x equals 0 to be 9 times negative 2, which is negative 18. So maybe the curve will make something like this. Okay. And then cut the curve at negative 2 and rebound here and make something like this. Okay, should be a curve. Okay, this is negative 18 and this is 2, this is 3. B, the graph of y equals ax minus 2, ax minus 3 all squared. Okay, we can write here for B, y equals f of ax, because we replace each x with ax. Pass it through the point 1 and 0, 1 and 0, which is this point. 1 and 0. So find the two possible values for a. To describe this problem well, we know the original points, which is 2 and 0, and we know the image, which is 1 and 0, and we know some information about the transformation because it will be stretch, horizontal stretch. But what is the value of a should be? It means that 2 should be multiplied by half to get 1. To multiply 2 by half, a here should be 2, you know. So in this case, the value of a should be 2. And the other possible value maybe come from 3. 3 and 0. 3 should be multiplied by 1 over 3, right? Which means that a equals 3. Because in case of horizontal stretch, we will multiply the x coordinate by 1 over a. The point R, 4 and negative 6 lies in the curve with the equation of x. State the coordinates point R after transformation y equal 1/3 f of 2x. Okay, in general here we can describe the problem as following. We have here 4 and negative 6, and we have the following transformation: 1/3 f of 2x. Okay, the y coordinate should be multiplied by 1/3, so that negative 6 should be negative 2. And for the x coordinate, it should be multiplied by 1 over 2, which is half. 4 times half is 2. To answer question 2 now, the point S, negative 4 and 7, is transformed to point S dash, negative 8 and 1.75. To describe this problem well, let's write it as the following. S here is negative 4 and 7, and the image is S dash, which is negative 8 and 1.75. Okay, what is the transformation should be? A f of bx. Very nice question. For a, we should know that 7 times a should be equals 1.75, or we can write it as, I think, 7 over 4, right? 7 over 4, which means that a equals 1 over 4. Very good. And for the value of b, we know that negative 4 times 1 over b should be negative 8. b here should be half, positive half. Question 5, the point 2, 1 lies on the graph of the equation y equal f of x. On the graph y equal f of ax, the point P is transformed to the point Q, 4 and 1. Determine the value of a. As we said before, the x coordinate here, which is 2, should be multiplied by 1 over a to get what? To get 4. So we can switch a with 4. Comes here and 4 comes here. Also a can be half. For b, write down the coordinates of the point to which p maps under transformation. The original point here is p, 2 and 1. After transformation of x minus 4, the x coordinate should be changed by adding 4 to it. So it will be 2 plus 4, 6, and keep y as it is. Okay, for the second transformation, 3 f of x, we will multiply the y coordinate by 3. So it will be 2, 1 times 3 is 3. And finally, for the third one, we have half f of x minus 4. So the y coordinate should be multiplied by half at first, and then minus 4. So look at the y coordinate. The x coordinate will be as it is. For the y coordinate, 1 times half, it will be half. Half minus 4, it will be minus 3 and half. Question 4, the diagram shows the curve with equation y equals 5 plus 2x minus x squared and the line with equation y equals 2. The curve and the line intersect at points A and B. Find the x coordinates of A and B. To get the x coordinates, we will solve this equation simultaneously. So we can equate the two y's together. 2 equals 5 plus 2x minus x squared. Rearrange the equation to be x squared minus 2x minus 5 plus 2, which is minus 3, equals 0. Okay, it will be x minus 3 multiplied by x plus 1, which means that the x coordinate of A, of course, will be negative 1, and the x coordinate of B will be positive 3, according to the graph. Question 5, the diagram shows a sketch of the curve with equation y equal f of x on separate axes. Sketch the curve with equations a y equals f of negative x, b y equals negative f of x. In the first one, all the x coordinates should be multiplied by negative 1, which means that the points which are on the right should be on the left, and those on the left should be on the right. Or in other words, we can make a reflection in y-axis, but in b, we will make a reflection in x-axis. As the following: in a, this point should be negative 2 and 0. And of course this is 0 and 0, and in B this point will be the same, 2 and 0. Okay, and this is the origin, of course. 6, the diagram shows the graph of the quadratic function f of x. The graph meets the x-axis at 1, 0, 3, 0, and the minimum point is to negative 1. Find y equal x squared plus x plus c. Very good. For this part, we will say that y equals a multiplied by x minus 1 times x minus 3. To get the value of a, we can use the information that 2 and negative 1 is point on the curve. So if we put x equals 2, y should be negative 1, right? X equals 2 means this bracket will be 2 minus 1, 1. 2 minus 3 is negative 1, so it will be negative a, which means that a is 1. And then y should be x times x, x squared, and then negative x, negative 3x, negative 4x, and finally plus 3, which means that a is 1, b is negative 4, c is 3. B on separate axes, sketch the graphs of y equals f of x plus 2. It's a horizontal translation with 2 units to the left, and y equals f of 2x, which means that we have a horizontal stretch, and we will multiply each x coordinate with half. For the minimum point, 2 and negative 1, 2 minus 2, it will be 0. So this is the point here. And for the point 3 and 0, it should be 1 and 0. And for the point 1 and 0, it should be negative 1 and 0. So the curve should be like this. This is 1, this is negative 1, and this is negative 1. in B double I here, all the x coordinates are multiplied by half. So we have here, instead of 1 and 0, we have half and 0. Instead of 3 and 0, we have 1 and 1.5 and 0. And instead of 2 and negative 1, we will have 1 and negative 1 as the minimum point. The y-intercept should be the same. It's 3, should be 3. Right? 7 f of x equals x minus 1 times x minus 2 times x plus 1. State the coordinates of the point which the graph y equal f of x intersects y-axis. Very good. To get the point, to get y-intercept, put x equals 0. X equals 0 means the first bracket will be negative 1 times negative 2 will be 2 times 1, it will be 2. For the second one, be here, the graph of y equals a f of x, vertical stretch with a, intersects y-axis at 0 and negative 4. We can describe the following problem. 0 and negative 2 will be transformed to 0 and minus 4 by the transformation a f of x. Of course, a here should be 2. It's very clear, right? A should be 2 because negative 2 times 2 it will be negative 4. See the graph of y equals f of x plus b passes through the origin. Very good. Here we will make horizontal translation. In this case, we should find the x-intercepts of the original function. We have 1 and 0, we have also 2 and 0, and we have finally negative 1 and 0. And then after the transformation y equals f of x plus b, the curve should pass through the origin. So we can describe the problem as the following. We have negative 1 and 0 as an example, say, okay, and after the transformation f of x plus b, it should be 0 and 0, right? So of course b here is negative 1, right? Because if b is negative 1, we will move negative 1 to the right with 1. So in this case b is negative 1. And for the second point, which is 1 and 0, b should be positive 1. And for the third point, which is 2 and 0, b should be 2, can be 2. Question 9a, factorize completely. Okay, very good. We will take x as a common factor, and then we have x squared minus 6x plus 9, which can be factorized to be x times x minus 3 all squared. B sketch. Okay, the curve should cross the x-axis at 0 and then touch it at 3, right? Because we have here square root 3 and this is the 0. See, the point with coordinates negative 4 and 0 lies on the curve with equation y equals x minus k all power 3. Okay, the new equation is the same as the previous one after replacing each x with x minus k. So we can write for part C that we are talking about what? Y equals f of x minus k. After this transformation, we have the points negative 4 and 0, and the required is to get the value of k. Okay, this is the point negative 4 and 0, right? The first case, 0 and 0 will move to be negative 4 and 0. And in this case, k of course will be what? K will be negative 4 because we want inside the bracket to be x plus 4, and this means that we will move the curve 4 units to the left. And for 3 to move to this point, we need to be k equals negative 7 and k equals negative 7. Question 11, given that f of x equals 1 over x, x doesn't equal 0, sketch the graph of y equals f of x minus 2 and state the equation of the asymptotes. Very nice question. The graph should be similar to 1 over x, but we will move it down to units. So the horizontal asymptote should be moved from y equals 0 to y equal minus 2, like this. So that the curve should be like the following, and like this. And the horizontal asymptote will be y equal minus 2. And the vertical asymptote will be the same, which is x equals 0. B, find the coordinates of the point where the curve y equal f of x minus 2 cuts a coordinate axis. Okay, which means this point, right, at which y equals 0. So 1 over x minus 2 equals 0 means that 2 equals 1 over x. Switch them so that x should be half. So the point will be half and 0, right? For part C, sketch the graph of y equal f of x plus. The required now is to graph or to sketch the graph of y equal 1 over x plus 3, right? Which means that the vertical asymptote will move to the left with negative 3, which means that the vertical asymptote will move to the left with 3 units, and the curve will be like the following, right? And the horizontal asymptote will not change. So the horizontal asymptote should be y equals 0, and the vertical asymptote should be x equals minus 3, okay? The question also said find the point that the curve cuts a coordinate axis. The question asks about this point at which x equals 0. For x equals 0 in this case, y will be 1 over 3. So the point should be 0 and 1/3. Okay, thank you for watching and see you in the next chapter inshallah. Assalamu alaikum.